Now, what if we change our lens and it will have first plane surface and the second surface will be concave? Okay, let's draw our lens. It will be something like this. Okay, and it has its own plane surface. So this is our surface, not plane but concave surface. So as usual, we have optical axis. And light hits this lens, passes through this lens. So when it hits plane surface at angle 90 degrees, because of index of incident angle of incident is equal to 90 degrees, nothing will change in this ray's direction. It will not change its direction, so it will pass through this surface. So after hitting the second surface, concave surface, the index of refraction our lens is equal to n. Because of that, it will change its direction and will focus our lens at some point F, at its focus, okay, its focal point. So this distance is equal to F. Okay. Now, because our ray is moving from surface, from the medium that has index of refraction n to the vacuum or maybe air, which has index of refraction less than n, okay, our ray will focus at this direction. So this is our direction. Okay, so it means that the n at this formula, let's duplicate it and move here. So it means that n will be changed. We cannot use this n because n prime will be 1 divided by n. Okay, we will use n prime because our our light is moving from the medium that has more index of refraction than second medium. Because of that, we will use 1 divided by n. Okay, f prime will be our just focal length, just f. So I can write here n prime multiplied by f is equal to n minus f prime minus 1 multiplied 1 divided by r. Or r is its radius of curvature of our second surface. So it's radius of curvature. Okay, let's put 1 over n instead of n prime. So my formula will be 1 divided by n multiplied by f is equal to 1 multiplied by n minus 1 multiplied 1 over r. Let me multiply both sides of equations to n. So my formula will be 1 divided by f equal to 1 minus n multiplied by 1 over r. So 1 over f, it's d, optical power of lens, but we see that here, here 1 minus n, it's negative number. Does it mean that focal point of our lens is negative number? No, because our ray is hitting concave surface. So this is less than 0. Also our ray is hitting concave surface. Because of that, our r, radius of the curvature, will be also negative number, so they will cancel each other, and the focal point will be positive number. So d will be if I move minus from these brackets, I will get minus n minus 1 multiplied 1 divided by r. This is the power of my lens, which has plane and concave surface. Plane and concave surface. Let me write it here as this one. It's nearly the same. I will duplicate it, but I will change the order of these words. So it's not convex plane, but plane concave. Plane concave. Plane concave surface. So this is our minus. Okay, now what are we going to do? Our goal was to make a lens, okay, and it's find its focal point to prove lens maker formula. Let's draw new lens, and it has both convex surfaces. Concave, it doesn't matter. For example, this kind of lens. So, for example, one surface is this one. So this is our lens, and we need to find its focal point, and the radius of the curvature of first surface is r1. Radius of the curvature of the second surface is r2. Okay, it has optical axis as usual. Optical axis. We need to find where will be our focal point, or we need to find the power of our lens. Okay, let's say this distance is f, and we need to find this f. Okay, our rays will pass through this lens. At the end, they will focus at this point, for example. I will not draw how are they moving inside of lens, but we surely know that it will focus at this point f. And what is this f? We need to find. Now let's split our lens. Imagine we split our lens, and it will have it will consist of two lenses. The first lens will be this lens. Okay, this is our first lens, and it has plane surface. It has its plane surface. We split it here. Okay, second lens also has plane surface, and it has also its concave surface. So it will be somewhere here. So the distance between these two lenses is very, very small. It's nearly zero. Nearly zero. We know that if we put two lenses very close to each other, their power will be summed up. So if we say that the first lens has a power of optic power d1, and the second one has optic power D2. The optic power of this system, of these two lenses, if they are very close to each other, D is gonna be D1 plus D2. We know that. We proved this formula. So now we know D1. Our first lens is convex plane surface lens. Yes, convex plane lens. Its power is equal to n minus 1 multiplied 1 over r. I will just duplicate this formula. Okay, I will duplicate this formula and move here. D, and it's gonna be D1 because this is our first lens, and R1 it's radius of the curvature. Second lens has plane concave surface, and we know the formula for that. It's this formula. I will duplicate these two and move here. D2 is equal to minus n minus 1 1 over R2. Now let's add these two formulas, these two equations, D1 and D2. This one is our first equation, this one is our second equation. If we sum up these two equations, we will get the optic power of our lens. So D is going to be D1 plus D2. Instead of D1, I will write n minus 1 multiplied 1 over R1 plus minus minus, okay, n minus 1 multiplied 1 over R2, and I will close brackets. It means my formula will be n minus 1, okay, sorry, n minus 1 multiplied 1 over R1 minus n minus 1 multiplied 1 over R2. Or I can write it as D is equal to n minus 1 over R1 minus 1 over R2. So this is the formula of lens maker. This formula will be 1 divided by f is equal to n minus 1 multiplied 1 over R1 minus 1 over R2. This formula is called lens maker's formula. This is our main formula, and we will use it to solve some problems. For example, what kind of problems we can solve? For example, let's say we have one lens and its radius it consists of two lenses. For example, let me first write that this is lens maker's formula. Lens maker's formula, and we proved it. So now let's say we have some lens. Okay, we have some lens and it has this shape, for example. Okay, it will be here, it's center, and we have another second curvature. It will be, sorry for that, it will be like this. So, for example, I have this lens. Let me write it as this. So this is my lens. Okay. This is my lens, and it has its own radius of the curvature, R1 and R2. We have optical axis here. Let me write it not as dots, but straight line. Okay, sorry. It's not a dot. We need straight line. So we need to find focal length of this lens. Radius of the curvature of first surface, let it be R1. Okay, and radius of the curvature of the second surface is R2. So R1 is negative number because it's concave surface, and R2 is also negative number because it's also concave surface. Okay, now let's write lens maker's formula, and what will be its power of lens, or focal point. Will it be negative number or positive number? So let's say that also R1 is less than R2. Module of R2 is bigger than R1. So lens maker formula will be T is equal to n minus 1 multiplied by 1 over R1 minus 1 over R2. We need to find the sign of this formula. N minus 1 is bigger than 0. We know that this is bigger than 0, and this one we can write as, okay, here we can write as n1, sorry, not n1, r1 multiplied by r2. Here we have r2 multiplied minus r1. So let's say we have some axis. Let's call this axis R, and for example 0 is here. It means that if R module of R2 is bigger, R2 will be somewhere here, and R1 will be between R2 and 0. R1 is 0. So between R2 and 0. So subtraction of R2 from R1 will be negative number. Why? Because, for example, let's say R2 is minus 4, R1 is equal minus 2, minus R2 minus R1, it means minus 4 minus 2 will be minus 4. So it's negative number. So I can say that R2 minus R1 is negative number. R1 multiplied by R2 is positive number because minus 4 multiplied by minus 2 will be 8, and it will be positive number. So this one is not correct. So it means that our power will be less than 0. It means that our lens is diverging lens. It will diverge all beam of light, beam of rays. That's all. We proved our formula, lens maker's formula. In the next video we will solve some problems.